Hi, so in this video I want to talk about the dunder-del method, the delete method. So it is a class finalizer. So what do I mean by this? Well, the garbage collector, remember, is the thing that destroys objects that are no longer referenced anywhere. Now we can hook into that lifecycle event, and we can do that by using this dunder-del method. So the dunder-del method will get called right before the object is destroyed by the garbage collector. So the garbage collector determines when this method is called, and that's really important to understand. We do not control when that delete method is going to get called. Even if you use the delete, let's say you create an instance of your class and then you use the delete keyword with your class, all you're doing is you're removing the reference that you have in your current scope to that object, but it may be referenced elsewhere, in which case the delete method is not getting called at that time. It's going to get called by the garbage collector when all the references are gone. So sometimes we call this delete method the class finalizer. Some people sometimes call it the destructor, but that's not really accurate because the garbage collector is the one that destroys the object. All we're doing here is basically injecting a bit of code that runs immediately prior to the object being destroyed by the garbage collector. So when does it get called? Well, that's the basic issue, right, with the delete method. We don't know when it's going to get called because we don't control when it's going to get called. So it's only called when all the references for the object are gone. So we have to be extremely careful with our code because it's easy to inadvertently create additional references or even circular references to instances of our objects, and we may not even be aware of that. For example, let's say that you use your object in an exception. You basically hold on to the stack trace. Well, the stack trace has a reference to that particular object. So even if you destroy the object, if you don't also destroy the reference that's being held by the stack trace, that object stays around and the delete method doesn't get called. So it's very difficult to determine when it gets called. And there's additional issues as well. If the delete method contains references to global variables or other objects, those objects might actually be gone by the time the delete method is called. So if an exception occurs in the delete method, the exception is not raised, it is silenced by Python. Python isn't going to raise an exception that happens in the delete method because basically it's in the process of destroying the object. It says, okay, if there's an exception, too bad, I'm destroying the object anyway. Now, the exception description is sent to the standard error out, but the main program isn't aware that something went wrong during that finalization. So instead, if you're thinking of using that delete method to clean up maybe a database connection or to clean up a socket connection, things like that, don't. That's really not the best place to do it. Context managers is what we want to use to ensure that we're cleaning up things and that we do so in exactly the time when we think we want to do it and when we know we want to do it, not leaving it up to the garbage collector so that it will eventually happen at some point in time. But that's not deterministic, and that's the primary issue with this. Personally, I don't use the dunder-delete method. I use context managers if I want to do things like cleanups, and I haven't just had a use for using the dunder-delete method. Some people do use it, and maybe you'll have a use case where you do want to use it. So it's important to understand that it's there and how it works and what the drawbacks of it are. All right, so let's switch to some code and let's just try that out. So thanks for watching, and I'll see you in a bit.